For permission over here. Yes? No? Oh, it is me. I don't have to ask myself for permission. Okay. Or I don't have to give myself permission. All right, so you wanted to look at homework 8, both of you. Okay. So let me bring that up. All right, now any particular problem? Start at the beginning. So I think these are all Laplace transform problems. So let's just look at problem number 1. Okay, so find the Laplace transform of f of t. So this is this sort of delayed function, 0 when t is less than 4, and it's t squared minus 8t plus 25. T is greater than or equal to 4. Actually, we don't care about what happens exactly at 4. Okay, so the first step that I'm going to do in trying to get the Laplace transform of this is convert it into that the heaviside step function notation. So this is going to be u4 of t. So it's going to start at 4, and then it's going to be this thing delayed by 4 units. So t minus 4 squared minus 8 times t minus 4 plus 25. Just taking the no. This is not shifted. It actually, this is its value when it starts at 4. It's not a shifted version of that function. Okay, so I want to get the Laplace transform of f. What I'm going to do first of all is bring up my handy table of Laplace transforms, which you will be allowed to use on the exam, of course. Okay, so let's see. This is probably a good one. I just Googled one. Doesn't really matter. Open image. So we actually do want to shift this thing, right? So we're looking at let's see. We have the resolution on this picture is terrible. Another one. So if we look at the Laplace transform of a shifted function, then this is equal to some exponential times the Laplace transform of the original function. So this is some quadratic shifted to the right by 4. So I want to figure out what that is. Let's see, how can I do that? Well, I can, let's see, I can complete the square, that'll be helpful. So if I have t squared minus 8t plus 25, this is equal to t minus 4 squared, which is t squared minus 8t plus 16. And then I want to add an additional, I cannot think of that, what that is, 3. Or sorry, 9. Right? Okay. So this, let me box this off and run into the other stuff. This is u4 of t times t minus 4 squared plus 9. Okay, so up to this point, everything makes sense? What I've done? Okay. So we need to be able to rewrite this thing. It's in terms of t, we need to be able to rewrite it in terms of t minus 4. So we've done that. So let's call this G, and we'll call this thing capital G. And we'll say our G is equal to t squared plus 9. Because that would be u4 of t, G of t minus 4. That were G. So I'll look up t to some power. Well, no, first I want, yeah. G of s is equal to what? It will be the Laplace transform of t squared. And looking at this table, I get 2 over s cubed. And then 9, I get 9 over s. So that means that the Laplace transform of f should be e the minus 4s times 2 over s cubed plus 9 over s. Okay, I'm going to try that out and see if it works. If it doesn't work, I won't put this recording on the internet. Just be for you. It's a exponential minus 4s 2 over s cubed plus 9 over s. Submit answers. Correct. Okay. Now I feel more confident. Do you want to just continue? I'm sorry, go ahead.
Why is G t squared plus 9?
So when I do this Laplace transform, I know that it's going to be this is something shifted forward by 4. So what I want is that, let me try to draw a picture of this. So let's say we have some kind of parabola like this, right? And this is 4. What we want is, well, this actually this function is, it just starts at 4. Let me do this in better colors. So this is some quadratic. It's delayed up to 4, and then at 4, it's some parabola going up, right? And so this is a shifted version of something else. And so that something else, actually should fill that in. So that something else is this, right? So when we do the Laplace transform, we can break it into two pieces. One piece will be the function itself, and the other piece will be the shift. Right. The Laplace transform only cares about what happens from 0 forward. So we're looking at something from 0 forward being shifted to the right by 4. So the shifting is this part right here. Put that down. That's the shifting. And this is the thing that's shifted. So we have to figure out what that shifted thing is. And the way I did that was this is the shifted version, right? Because it's starting at t equals 4. So I want to figure out if f of t is t squared minus 8t plus 25, what is this equal to as g of t minus 4? What is g of t? That's what I'm trying to work backwards towards. So the way I did it was I did completing the square on this thing. So I said that this was equal to this, completing the square. And it turned out that the square was actually t minus 4. So that's the input. That's the thing that I'm giving to g. So if g gets an input of t minus 4 and it gives out t minus 4 squared plus 9, then g of t has to be t squared plus 9. It's kind of a little bit of working backwards, but that's the idea. So anyway, that's the kind of reasoning part of it. And then the applying the table is just figuring out what the transform of this thing is. The table also gives us what the factor is for the shift as well. Okay, let's see. A graph of f of t is given in the figure. Represent f of t as a combination of Heaviside step functions. Use h of t minus a for the Heaviside function shifted a. Okay, so this is just a conversion. Do you want to see this one? Is this an interesting one? And number 2, I should say. So we have some kind of graph, and it's kind of like a hat function like that. Do you want to see this one worked out? Okay. So let's see. The peak of the hat, the tip of the hat is happens at t is equal to 2, and the height is 4. So this is not to scale, but this is the f of t axis, the t axis, and so they say fill in the blanks for the piecewise function, or this is their hint. Well, we're gonna it starts at 1 and it ends at 3. The brim is it's 2 units wide. We're just going to go straight into it. So this starts off at 0 for a while, and then it turns into this thing right here. This thing it has a slope of 1 and a y-intercept of, we track this down, it goes, when we go back 1, it goes down 1. So if we go back another one, it goes down another one. So this should be -1. So it has a slope of 1 and a y-intercept of -1. So this is y equals x minus a little more room. Y equals x minus 1. So for that segment, from here, from 1 to 2, well, let's go ahead and let's not write it out. It's 0 for a while. F of t. F of t is 0 for a while, and then all of a sudden, at 1, this function turns on. it's x minus 1. And it goes until 2. Then at 2, it goes downward by a slope of 1. And if we work out what this one is, let's see, when we go backwards, oh, sorry, my bad. It didn't go down by 1, it went down by 4. And we went back by 1. So if it goes back another 1, it goes down another 4. It should be minus 4. Forgetting that this is not to scale. Okay, anyway, when we go forward, here by 1, we go down by 4. So if I go back 2, I'm going to go up by 8. So that's going to land me at 12. Right, this was a slope of 4. All right. So this time the slope is negative 4. I'm kind of doing this. I'm doing this kind of roughly because I'm assuming that you've seen the formula for a straight line. Anyway, this one is minus 4x plus 12. I did this by figuring out what the y-intercept and the slope was, but you could also do it by doing point slope formula or 2 points and figuring it out. Whatever, it doesn't matter. We have 2 endpoints here, so that's a particularly convenient way to do it. Anyway, now that is not quite right because this function has to compensate for this one right here too. It has to subtract that one away, right? Because we have this one turning on here, and then we want it turning off here, so we need to subtract it away. So I'm going to subtract away minus 4x, and then minus 4, that's plus 4. Okay, so that's to compensate for that. And then at 3, I'm going to cancel everything out. So what do I have left? At u after 2, I have that much of the function left over, right? I've canceled out the 1 to 2 part. Now I want to cancel out the 2 to 3 part. So I'm going to subtract away 4x, negative 4x, and I'm going to subtract away 12. And this is my function. Now I'm going to rewrite it so that it's in a form that WebWork will accept. So first, clean it up a little bit. u1 of t times 4x minus 4 plus u2 of t. I'm going to simplify this one to be minus 8x plus 16. Right? It's going to have a really steep downward slope and a really high y-intercept, but like this is going to be a line that's going down very steeply, but part of that steepness is going to be canceled out by this part right here that's still active. So we get exactly what we want. And then u3, 4x minus 12 to cancel out the remaining part that turned on at t is equal to. So that from this point on, the output is 0. And then finally, they're using h, I believe, for the Heaviside step function. And so for u1, that's the unit step function shifted forward by 1. That's like this. Like that. And I will type that in for verification. So 4x minus 4 minus 8x plus 15 t minus 3, 4x minus 12. Oh, of course I did something foolish, and you probably noticed I wrote x's instead of t's. Mentally fix that problem. Here, I'll fix it. I'll do it like this. Problem solved. Mathematically, I have solved the problem. However, WebWork does not accept that. I simply declare that t and x are the same thing. Okay, now it says I'm correct. Okay, so this one, we are finding, we're going to say f, capital F. This is the Laplace transform of something, e to the minus 7s squared minus 2s minus 15. And we want to figure out what that something is. So we're going to say, what is the inverse Laplace transform of f? Well, I don't need to write. Okay, so I'm going to split this up into two pieces. We've got the exponential. And so the exponential is going to correspond to a shift. So it's going to be e to the minus 7s times 1 over s squared minus 2s minus 15. So this is the easy part. Whatever the inverse Laplace transform of this thing is, that's going to be, it's going to be that thing shifted. So what I'm going to do is try to figure out what the inverse Laplace transform of the underlying part. And to do that, we of course use what does this factor easily? Hey, it does. All right. Let's use partial fraction decomposition. Let's see if that'll work. So this is 1 over, oh, it does it? Okay, yeah. S minus 5, S plus 3. So now I need to do my partial fraction decomposition. And that is going to be 1 over S minus 5, S plus 3 equals A over S minus 5 plus B over S minus 3, or 1 is equal to A times S plus 3 plus B times S minus 5. So we get A plus B is equal to 0, and 3A minus 5B equals 1. And yeah, you just got to solve it. So everybody, do you agree with me up to this point? Okay. So it's just you take a deep breath and you dive in. So I'm going to multiply the top one by 5. Of course, we could do this with matrices, or we could do substitution or whatever you like. It doesn't really matter. Kind of the amazing thing about math, that there are all these different ways of doing things. Sometimes I'm amazed that I do the same problem in two ways that seem like completely unrelated, still get the same answer. Like magic. Okay, b is negative 1/8. That's easy to see from this equation. And so what we get is that, get rid of this, back to that. We're still trying to figure out how to write fs. This is going to be e to the minus 7s times one-eighth over s plus 3 and s minus 5 plus b over s minus 3. So in order to figure out the inverse Laplace transform of this thing, well, let's give these things names. Let's call this G. Change the color. Let's call this thing G and this thing H. For B. Okay, and it should be plus 3. Always pays to just take a moment after you've written something, look at it, and see if it makes sense. I do that sometimes. Okay, so let's go back to our handy table of Laplace transforms. So we have the Laplace transform of a shifted 1 over s. Well, we can think of that as a shifted 1, or we actually have a kind of a handy Laplace transform, so you don't have to think about it so much. The inverse Laplace transform of 1 over s minus a is just e to the a t. So now it's not the input to the Laplace transform that's shifted, it's the output. But the shifting works in the other direction as well. It actually turns into this factor of e to the at. In this case, it's a positive a instead of a negative. So the shift results in a positive a. So what do we have? We have the shifted version of, let's see, we'll write g of t. This is 1/8 e to the 5t. H of t equals negative 1/8 e to the negative 3t, because it's being shifted backwards by 3. S minus negative 3. Okay. So now we're going to get f of t. This is going to be the shifted version of g plus h. So it's going to be shifted forward by 7. So we need to turn it on its, thank you, tablet. You knew exactly what I didn't want to do. Yes. 8%, but okay. Shift forward by 7. So we want this thing to turn on at 7. And then we want the g and t to be shifted forward by 7. So this will be 1/8 e to the 5 times t minus 7 minus 1/8 e to the negative 3 times t minus 7. Now, hopefully that's right. And of course, this is, we can write this as h of t minus 7. For web work to be satisfied. Oh no, they say step. In this one, they say step. Who wrote these problems? The answer is not me. I can tell you that. 1/8 times exponential 5 times e minus. I shouldn't complain too much because I do know who wrote at least some of these. And they're saving me a huge amount of work by doing this for me. Shouldn't -3 times e minus 7, matching parentheses. Correct, first try. Makes you feel good. Okay, next problem. What do we have? Consider the function. I always like to just take a second to consider it. Use the graph. That's a dad joke, right? Use the graph of this function to write it in terms of heavy side and then find the Laplace transform. Okay, we'll try to do this all in one fell swoop. It's kind of before I go on. Do you want to see this one? Let's I'll start writing it, and if you're like this is boring, go to the next one and just yell at me. So f of t 0, 6, 0. So if t is from 0 to 5, I'm going to just write less than to emphasize the fact that the endpoints do not matter at all. Unless we've got like that Dirac delta function, which isn't really a function at all. The less than infinity, you don't need that either. The value at a single point does not matter. So, we don't care about that. Anyway, this one is pretty straightforward. It turns on at 5. So u 6u 5 of t minus 6u 9 of t. So it turns on a value of 6 at 5, and then it turns it back off, so we subtract it away. Kind of fun that we can take these logical ideas, express them as a mathematical expression. Okay, so it just wants the Laplace transform of this thing. Laplace transform of f. This is, let's see, how do we do this? The shift. So this is, I'm just going to look at the thing so that I don't confuse myself. So there's an implicit, the 6 is in terms of t minus 5. Doesn't really matter. So what we have is e to the minus 5. I just want to say, just to emphasize this, you already know this. The Laplace transform is a linear transformation or linear operator. And so we can actually do this piecewise, just like we would do a derivative or an integral. So it's 6 times e to the minus 5s. Now we're in the s plane. And then the transform of 1, which is 1 over s. So let's write it 6e to the minus 5s over s minus 6e to the minus 9s over s. Double check to make sure. Normally, the function that we're multiplying, the function that we're shifting, in this case, it's just a constant 6. We would have to rewrite that in terms of t minus 5, or we would plug in. We would have to figure out what it is, t minus 5. But 6 in terms of t minus 5 is 6. Okay. So check it or not check it. Let's go ahead. So 6h of t minus 5 minus 6. I should probably put a multiplication, so it doesn't. 6h is the name of t minus 9, and then exponential 6 times exponential 5s divided by s minus 6 times s. Like I'm in the class. This class. Okay, got it right. Congratulations to us. Okay. So this one, we want to find the Laplace transform of this function. So they say this function is 6 minus t times h of t minus 1 minus, oh, they've done this interesting rewriting. So maybe this is good to talk about. They've got this function 6 minus t, and this function turns on at 1. Well, let's rewrite this in the way that we're familiar with it. u1 of t times 6 minus t minus u4 u4 of t times 6 minus t, or u1 of t 6 minus t plus 4t t minus 6 t minus, yeah. So what we have is something that turns on the function 6 minus t at t is equal to 1. And then it turns off this function at t is equal to 4. And so what we end up with is something that just stays, well, it just suddenly drops to 0 and then disappears, stays at 0. If I want to get the Laplace transform of this thing, what I was going to say, this is an interesting way of writing this kind of turning it on and then turning it off. So this tells us where it turns it on, and then subtracting it away tells us where it turns it off. That's an interesting way of writing. Makes the what they're trying to express kind of intuitive. So let's get the Laplace transform. This is going to be, well, let's put it into a form so it's easy to write. So we had this function shifted. It's the 6 minus t that's being shifted. So we're going to shift the 6 minus t. It goes forward by 1. So we want to write it into t minus 1. So this is equal to u1 of t times, I'm going to write, well, let's just do it up here. 6 minus t equals t minus 1. Well, it's going to be a negative t minus 1. So that gives me a plus 1, so I need another 5. Make sense? And t minus 6, well, I'm going to rewrite that as t minus 1 minus 5. So I can say that these are if I take g of t, I want g of t to be t minus 5. So that makes inputting t minus 1 here g of t minus 1. So this is g of t minus 1. And this will actually be negative g of t minus 1. Right. So I'll write it like this. u1 of t, g of t minus 1. Oh, no. Made a mistake. I want this to be in terms of t minus 4. I still want g to be t minus or g of t to be t minus 5. Okay, this will still work. That top line will still work. But t minus 6, I want this in terms of t minus 4 because that one's shifted forward by 4. So this will be t minus 4 minus 2. So we'll have an h of t that is t minus 2. And when we plug in t minus 4, we'll get this thing. So this is u4 of t, h of t minus 4. So the Laplace transform of this thing, it's going to be e to the minus t, that's going to, or sorry, e to the minus s, that's going to be the shift. And then we're going to get the Laplace transform of g of t, which we could call capital G. But that's fine. It's just, what's the transform of t? 1 over s squared. Oh, this isn't actually negative g of t minus 1. So let's put the negative out in front here. So that's the t, and then minus 5 over s. And plus e to the minus 4s, so that's our shift. And then the h is t minus 2, so t will be 1 over s squared, and 2 will be minus 2 will be minus 2 over s. So we'll try it again. Negative exponent negative s times 1 over s squared minus 5 over s plus exponent s over s squared 2 over s. That, oh, every time I'm thinking it's going to be the first time that I got one wrong. Turns out to be wrong. I can't actually do this. I can do this stuff, believe it or not. Okay. So use the Laplace transform to solve the following initial value problem. Y double prime plus 4y prime equals 0. Y of 0 equals negative 3. And this is a problem we actually already know how to solve, not using the Laplace transform. So they get around that by making you, in the first step, they say find capital Y for the Laplace transform. Find the equation you get by taking the Laplace transform of the differential equation. Okay, so the Laplace transform of y double prime is s squared capital Y plus s. And I think I've said this before. The way I kind of think about this is, I know this is going to be s times y sub 0. That's negative 3s. Apologize, I didn't sign this before. Now I'm getting calls from numbers I don't recognize. Let's see, how should I say this? Am I doing this backwards? I've got the, no, I'm not. except subtraction. But yeah, I've got my two tricks for remembering how to do the Laplace transform. So the powers of S go down. And so this should be plus 4. Yeah, okay. So the trick that I use for remembering this is that it kind of corresponds to what you get for the definite integral. So you have, if this, you think of this capital Y as sort of like the integral of Y. It's kind of related to the integral of Y. So this is going one step up from the solution. In the next step, we do Y0, so capital Y, and Y0, and Y prime of 0. And if there was another step, we would have Y double prime of 0, and so on. We had higher order derivatives. So they increase or they decrease starting from the Laplace transform to the function itself to its derivative to its second derivative, and so on. These powers of S decrease going to the right. And also going to the right, you think of this thing as the upper limit, and then you're subtracting away the lower limit. You're subtracting away this part. That's the kind of mental trick that I have. Anyway, 4S capital Y minus -3. And so that's the whole left-hand side translated. So we've got that. Now, if I make a mistake, don't feel like you're going to embarrass me. So you'd be doing me a service. Okay, now solve for Y. Will do. So what do we have? S squared plus 4S Y. Of course, we knew we were going to get the characteristic polynomial multiplied by Y there. Equals minus 3S minus 7. Yep. And then capital Y is equal to S squared plus 4S over, I'm going to write it like this, 3S plus 7, and minus out front. Okay. Fingers crossed that we've got this right. Web work would allow me to know if I'm getting it right. Oh, what do they want me to do next? Partial fraction decomposition, of course. Now, let's answer above. You see, you were supposed to point out that I made a mistake here. Didn't do it. I trusted you. Minus 3S minus 7 over S squared plus 4S. Never again. I'll never trust you again. So this is minus 3S minus 7 over S times S plus 4. And we're going to have this as A over S plus B over S plus 4. So I get minus, I'm going to do this in a different color into the other stuff, minus 3S minus 7 equals A times S plus 4 plus BS. And so what we get is A plus B equals -3. And for A, yeah, 4A equals -7. That seems unnecessarily messy. They're giving us fractions here. So A is equal to what is it equal? -7/4. And B is just -3 minus -7/4 plus 7/4. And this is equal to -12 plus 7/4, which is that work out to be noise? No, of course not. Minus 5/4. So we've got our A and B. Shifting back to black pen, I get minus 7/4 over S plus, I'm just going to write it as plus the negative fraction over S plus 4. Okay. Are we in agreement for the most part? Now by inverting the transform, find y of t. Logical next step. So the first one is, well, that's easy. Negative 7/4. The next one, we're going to have subtract 5/4 e to the minus 4 t. I agree with the Laplace transform. Okay. Not typing all this in. So what do I get? I get s squared capital Y plus 3s plus 4. Sometimes it's good to just do it all at once. Just have confidence. See what? Sometimes it works. Sometimes you see that your confidence was not just. It's a gamble. 4s. And then what I get for this is minus 7/4 over s plus minus 5/4 or plus 4. And then by inverting it, a minus 7/4. I'm really tempting fate by doing it all. But submit answers. Everything was incorrect. Literally everything. Okay, what did I mess up? What did I mess up? Really? Ah, you see it? You see it? The mistake? I'm going to pretend that I did it intentionally to get you to no? Where did I go wrong? I'm going to keep putting the pressure on. It was in the very first step. All that talk that I was doing about trying to do it all in one thing. Big mistake. I had the opportunity to check my. This should be a 12 because it's 4. I'm sorry. Yeah, 4 times 3 should have been a 12. Okay. Anyway, let's have okay. So it says that's correct. If I go back and replace the minus 7 by minus 16. Say it's correct. Yes. Okay. Can we do this? And you remember the thing I said about this is unnecessarily complicated because they're fractions. Guess what? There aren't fractions. That should have been a hint to me. But I'm a fool. Okay, -4. So it's not too bad fixing this. And so now b is 1. And this should be -4 and plus. Go straight to the last step, see if we got it. -4 plus e to the minus 4t. Okay, let me have this one. Yep, that's right. Okay, no big deal. I don't have to put this on I can cut this part out. Cut that part out. Okay. Oh, it's actually 11:30. Do you want me to keep going? I can keep going. I don't have anything to do except like call banks and try to get a good interest rate on a mortgage and rewrite my dissertation. Take a shower, eat lunch. No, I can keep going. I can seriously keep going. You want one more? Yes? Okay. One more. Problem 7. Now I'm having a good time. Do the exact same thing. Okay, I'm going to remember my mistake. Y double prime minus 8y prime plus 41y equals 0. Now this is the next problem, so I'm not expecting this to be as easy. So what do we have? I'm not going to jump straight to the formula. I'm going to use the Laplace transform. So this is that. Now the next term is going to be y0, which is 0. So I'm just going to skip that one. And I'm going to be subtracting away y prime 0. So that's -5. Now -8 times, I'll make the same mistake, sy minus 0. Well, wasn't much of a chance of me making a mistake on that one. And then plus 41 capital Y equals 0. And so let's see, what do we get? S squared minus 8s plus 41y. I might have noticed it last time if it had been in the characteristic polynomial part. Okay. Equals 5. Roll. There we go. Capital Y is equal to 5 over s squared minus 8s plus 41. Okay. So 41. 41 a prime number. Let's see. 3 does not divide it because 4 plus 1 is not divisible by 3. Not a multiple of 7. It's not a multiple of 5. And that's really all that we need to check because the square root is less than 7. So we can't factor it easily. But we can complete the square. So this will be 5 over s minus 4 squared. And I'm going to do this to the side. S squared minus 8s plus 16. 41 minus 16. I should be able to do this in my head. No, 25. And that works out nice because this is a square, so we can, and the square root is in the numerator. Fantastic. Okay, so this is 5 over s squared, that's shifted, plus a squared. So this should be a shifted. Let me look at the table just to double check to make sure I don't screw this up. But it should be y of t is going to be oh, they actually have it in the table. That's really convenient. They have cosine shifted. I want sine shifted. You don't have that? This is one that I'm supposed to just know, I guess. But where do they even have sine? Okay, here we go. So this should be e to the 4t sine of 5t. Do you agree with me on that? We have a over s squared plus a squared. Yep, that's this goes to, or I should say, sine of at goes to this. But it's shifted by 4, and that should be a positive e to the positive 4. Let me throw that in there, jumping straight to the last step. E to the 4t sine of 5t. Times, not, yep, that's right. So that's the trick here is completing the square, and then you can use that shifting of in the s plane, not in the on the t line in the s plane, to get the same kind of. That's kind of interesting and unexpected that we do get this, but we have this shifting corresponding to multiplication in both directions of the Laplace transform. So it applies to the Laplace transform and the inverse. It's kind of interesting. Anyway, I think I'm going to call it there for today, unless, well, we started about 10 minutes late, so we can end about 16 minutes late. That's fine. If you, I guess I'll stick around if you have questions, but otherwise, I'm going to go take a nap. Bye.